Good day, ladies and gents, and welcome to another episode of StomanMaths. In this lesson today we're going to have a quick look at rounding off, and I'll show you just how easy it is to do it. Okay, so if you understand it, it's really quite easy. It's not a lot of effort to round off. Okay, so we'll begin with two numbers that you might already be familiar with. Okay, we did these two numbers in one of my earlier videos in rational and irrational numbers. So let's go and have a look at the number, the square root of 2. And we'll also have a look at another of the irrational numbers, and that is the number pi. Alright, so for now I'll take my calculator and I'll punch into it the square root of 2, and that gives me a very large decimal number, which is 1,414213562. And if I do the same, I take my calculator and I ask it to give me the value of pi. Alright, it's going to give me 3,141592654. 3,141592654. Okay, so now let's go and have a look at rounding off the decimal portion of these numbers. Alright, now usually when you are asked to do some rounding off, or when you are asked to round something off, the question will sound something like this: round off this decimal number to the fourth decimal or to the second decimal. Alright, and when you're writing your exams, usually in the exams there will be an instruction that says something like where it's not specified, round all decimal numbers off to the second decimal. So what does that mean? Well, if they say the first or the second or the third or the fourth decimal, doesn't really matter. It's just the number of decimals that must be left over on the right hand side of the comma after you've completed rounding off. So if I talk about the fourth decimal, then I want there to be 1, 2, 3, 4 numbers, and only 4 numbers after the decimal, after the comma. So if I say round off to the fourth decimal, you must round off so that this portion is taken away and I'm left with only 4 numbers after the decimal. If I say round off to the second decimal, it means that there must only be 2 numbers after the comma. Alright, so basically I want to round off so that this whole portion of the number just eliminates. Okay, it's not that we are throwing it away, but it's too much effort, it's too cumbersome to keep on writing out this whole decimal number all the time we want to use the value of pi. So to make our lives easier to see, to read, easier to understand, we round these numbers off, and then we get to some estimation of what the original number was, but the estimation is still very, very close to the original value. So that is why we round off. Okay, so it's to save us some time and space, and to save our poor eyes from having to read these large decimal numbers all the time. Alright, so we'll do a couple of examples. First off, let's round off to the fourth decimal. Okay, let's round off to the fourth decimal. So when we do rounding off, or when we go ahead and we want to round some numbers off, and the question is given to us, or the request is given to us to round off to the fourth decimal. So what we do is, we take our number and we count 1, 2, 3, 4 decimals, and at that point we put an imaginary line. We put an imaginary line in our number, in our decimal number. And then the next thing that we do is we go and have a look at the number, the value that is immediately to the right hand side of that imaginary line. Okay, so 1, 2, 3, 4, and we put an imaginary line in, and we go and have a look at the number that's immediately after or immediately to the right of that imaginary line. Okay, now we've got a rule to apply, and that rule is the following. If this number, the number that is immediately to the right of our imaginary line, if that number is less than 5, alright, less than 5. Then we round it downwards. And I'll show you just now what I mean by that. So we round downwards. Okay, if the number is less than 5. But if that number to the right hand side of our imaginary line is equal to or greater than 5, all right, equal to or greater than 5, all right, then we say we round up, we round upwards, and I'll show you what I mean by that just now. So then we round up. Okay, so now let's go and have a look at our first case. We see here after the 4th position, that number that's immediately after our imaginary line is a 1. And that 1 is obviously less than 5, okay? So it means we must round downwards. Now when we round downwards, it means that all of these become zeros. So it was a 1 and it comes down from the 1 to a 0. So that's why we say we round downwards. Okay. And if we round the square root of 2 down to the 4th decimal, it only becomes 1,4142. We don't have to write all of these zeros afterwards, okay? If we end it with a 2, it's implied that the rest of these numbers are zeros, but we don't have to write it, okay? So we just know, we just know it's going to be an endless number of zeros, and an endless number of zeros, they don't mean anything, so we don't have to write it. So in this case now, we have rounded it off to the 4th decimal, and what we had to do is we had to round downwards. So now we have 1, 2, 3, 4 decimal numbers, exactly as the request was given to us. Let's go and have a look at pi. So now, this number, the number 9, which is now directly after our imaginary line, is greater than 5. And now we must round upwards. Now when we round upwards, it means that we are counting upwards from wherever that number was. So our number is 9, which means we are greater than 5. And if we round upwards, the 5, this number, that's to the left of my imaginary line, goes to the next. It goes up to the next number, which is then 6. And the rest become zeros. Okay, so that's what happens when we round upwards. So if we were to round off the pi, the number pi, to the 4th decimal, it would be 3,1416. 3,1416. Again, there are a whole lot of zeros right after the 6, but a whole lot of zeros is still 0, it's still nothing, it still means nothing, so we don't have to write it. It's implied that there are a whole lot of zeros after the 6. Okay, so this is your rule. Rule number 1 and rule number 2. If it's less than 5, we round downwards. And if it's greater than or equal to 5, we round upwards. Okay, so let's practice one more number if you want to. So let's take our calculators. I'm just going to choose some kind of an arbitrary number. Let's choose the square root of 3. Let's choose the square root of 3. Okay. And the square root of 3 we'll take the 4th decimal. And that means there must be 4 numbers after the comma. Okay. So we are going to have to do some rounding off, and we are going to have to get 4 numbers after the decimal. So if you use the square root of 3, you punch that into your calculator, you will get the following: 1,73205 0808. That's as far as my calculator goes. Okay, and what did we say we do? We count. We want the 4th decimal, or the rounding off to the 4th decimal, so we count 1, 2, 3, 4, and then we put down our imaginary line, and we have a look at this number that is directly after or directly to the right, immediately to the right of that imaginary number. And in this case, we can see that it's a 5. And so the rule says if it's 5 or greater, if it's equal to or greater than 5, we are rounding up. When we round up, the 0 must now turn into a 1 and all of the rest turn into zeros. Okay, so to the 4th decimal means that this number now becomes 1,7321. 7321. Okay, now have a look at the actual value of the square root of 3, which is this whole big number here. And remember, it goes on and on and on and on and on and on and on. Okay, our calculators just don't have enough space to show that entire number. So it'll go on up to infinity. There's no pattern, there's nothing, it's an irrational number. Okay, but we don't want to have to write this whole slew of numbers every time we want to use it. We round it off. So 1,7321 is not exactly the same as this big decimal number here. Alright, but it's close enough. It's close enough because we've got 1, 2, 3 decimals which are the same, and then from here on in it's slightly different. Okay, but that difference is so small that we can take it as it being more or less the same number. More or less the same number. Okay, so rounding off is a very neat trick we can do to make our numbers a little smaller, a little easier to look at, a little easier to do our calculations with, and just in general easier to read. Alright, so let's finish it off with just one more example. We'll take the square root of 3 again, and I'll ask you round it off to the 2nd decimal. Alright, round it off to the 2nd decimal. See if you can do that. Pause the video here. See if you can do that rounding off, that exercise. Okay? And if you've done it now, the answer will be 1,73. Alright, how did we do that? How did we get that? If we go and count 1, 2, because we want the 2nd decimal, 1 and 2. So we put our imaginary line right here. And we go and have a look at the number right next to that imaginary line. That's a 2. 2 is less than 5, so we round downwards, and it just means that all of the rest of these numbers become zeros. All of the rest of them become zeros. We don't have to take the 3 back to a 2. We don't do that. It's just that all of them become zeros. When we round up, yes, then the 5 must become a 6. And the 0 must become a 1. Okay, like we had here in this case. But when we round downwards, we don't have to change the number to the left of our imaginary line. And there you have it, quick and easy. Okay, I hope you understand rounding off a little bit better. We will do so many examples, and even in mathematics and in your science classes, that rounding off will become second nature, and you'll do rounding off without even thinking about it. But if this is your first introduction, okay, good. And I hope you understand it today. Thank you very much for your attention. Thank you for joining me today for this short little video on rounding off. I hope to see you in my next lesson. Like and subscribe and all that good stuff. Stay well, and I'll see you again. Bye-bye.